Okay, today's date is the 18th. Today we're going to talk about solving compound inequalities. We have two kinds of compound inequalities. We have inequalities that are connected using the word and we have inequalities that are connected using the word or. So we're going to talk about how strategies for solving both of those. And this goes exactly with our standard, right? Or solve compound inequalities and graph their solution sets on a number line. That's exactly what we were doing. Everything we've been doing so far has been leading up to this moment. So this is where we need to be. It also says may include absolute value inequalities. We'll be talking about those coming up here in a few lessons as well. Okay, so our first objective is solving compound inequalities with and. When you have a compound inequality with and, we sometimes write it as what looks like a sandwich inequality. So we have a variable, maybe with some other terms combined, in the middle, and then we have values on either side. So it's telling us that the variable is going to be in between two values. When we solve compound inequalities, we solve them the same way that we solve regular inequalities, but instead of just having two sides to deal with, when we have this type of inequality, we have three sides. So instead of adding 4 to both sides, we add 4 to all three sides. So that's the only difference. We're still trying to isolate the variable. We want to get m by itself. So what I need to get rid of is this minus 4. I get rid of it by adding, and I have to do it to all three sides. Negative 3 plus 4 is positive 1. I still have less than or equal because I didn't multiply or divide by a negative. Negative 4, positive 4 is 0, so I just have m left in the middle. Negative 1 plus 4 is 3. So once I get to that naked variable in the middle, just the m with nothing attached to it, I am done. So m is in between 1 and 3. I'm going to use a closed circle on 1 because it's greater than or equal to 1. So I'm going to use a closed circle. On the number 3, I'm going to use an open circle because m is less than 3 but not equal to 3. So I use an open circle, and then I draw a line connecting the two. Don't draw arrows when you're doing an and inequality because arrows would imply that it keeps on going, which would mean any number would be true, and any number is not true. We can also check when we get an answer to see if we're right. So I could pick a number outside of this range to see if it works. I'm just going to pick 0 because 0 is easy to work with. If I put a 0 in here, I have 1 is less than or equal to 0 is less than 3. That's not true. 0 is not between 1 and 3. So I shouldn't have 0 labeled, and I don't. So I did right. Next, I'm going to try 2. 2 should work. So if I have 1 is less than or equal to 2 is less than 3, that's true. That works. And you can also check it back in the original equation. I could do 2 minus 4 is negative 2. Negative 2 is in between negative 3 and negative 1. So you can check points that are inside of what you've graphed and outside of what you've graphed to make sure that they make the inequality true. Question?
What's the point of recording this if it sounds like you're lagging 100% of the time anyway?
We'll talk about that later, okay? Stay after and we'll talk about it. All right, next one is one for you to try. So you're going to do the same type of thing. This is a two-step. So you're going to have to eliminate the negative 4, and then you're going to have to eliminate the 3. So I'm going to pause the recording, try it, and then check back.
Oh, good math.
Okay, Ashley, can you tell us how we would do this problem? Good. Add 4 to all sides. Okay, what do we end up with? 2. 3y. Less than? 18. Okay, now what do we do? Good. Divide them all by 3. Okay, so 2 divided by 3, we can just leave that as 2/3. We don't have to divide that through. So 2/3 is less than y is less than 6. So when I graph it, I don't have a 2/3 on my number line, but 2/3 is going to be, if we were to divide in between 0 and 1 into 3 sections, it would be like the second little line. So it's not going to show up very well here, but I'm going to do negative or 2/3 would be maybe about there. And then my upper limit is 6, line between. Okay, I want to do another example that includes some negative numbers. So I'm going to do -10, just write this one in. This is a write-in. Okay, now remember when we're solving inequalities, if we multiply or divide by a negative number, we have to flip the sign. This problem was on the quiz yesterday, when you had to flip the sign, and only half the class got this right. I don't know if you kind of read it wrong or if you're a little confused about that. Some of you chose that if there's a negative number involved, you flip the sign. But that's not always true. It's only if you multiply or divide by a negative number. Adding or subtracting doesn't work. Multiplying or dividing by just any number doesn't work. It has to be negative. So in this case, we are going to need to divide by a -2. So because we're dividing by a negative number, we are going to need to change our signs. So -10 divided by -2 is +5, and we need to use greater than x greater than or equal to -10. Now when you graph this, -10 on the number line is farther to the left. You might want to flip it around and think this is actually -10 is less than or equal to x, which is less than 5. So on the number line, I'm just going to do 0, 5, and -10. It's going to be in between -10 and 5. Like that. You could graph it from here. It's not wrong to write it this way, but it looks better this way because it's in the same order that you see it on the number line. Okay, now we're going to talk about solving compound inequalities that have the word or. Ernie, you still writing? I'll give you a second. Negative. Oh, from here, -10 divided by -2 is 5. Page? Okay, now we're going to look at solving compound inequalities with or. When you have the word or in the middle, you're not going to put them together like you do a sandwich, because most or inequalities result in graphs where one arrow goes one way, the other arrow goes the other way. It's not always true, but 95% of the time, probably, the problems that you do an or inequality, it's like oars on a boat. Like you're in a boat and you've got oars sticking out on each side, you know, O-A-R, or. So that might help you remember what these are supposed to look like. So when we have an or inequality, you'll see it in a second. When we have an or inequality, we have to solve both sides separately. So we're first going to solve this inequality on the left, then we'll solve the inequality on the right. So first I'm going to subtract 2 from both sides. I get 3t is less than -9. Dividing by 3. Now I don't need to change my sign because I'm not dividing by a negative number. I'm dividing by a positive number. So t is less than -3. Or I need to solve the other half. I'm going to subtract 5. I get -4t is less than -4. Now I'm going to divide both sides by -4 because I'm dividing by a negative number. Whoops, I'm right on the slope there. Because I'm dividing by a negative number, I'm going to need to flip my sign. So I get t is greater than 1. So either of these two things are true. Either t has to be less than -3, or t has to be greater than 1. Do you see what I mean now about like oars on a boat? Like here would be your, maybe your canoe, a little seat in there, okay? Someone sitting in there, and these are the person's oars sticking out on either side. They don't always work out that way. There are some times when you'll have 2 arrows going in the same direction. We'll see some examples of that in the homework, but most of the time they go out to the side. Okay, any questions about the or kind? Okay, here's one for you to try. And this is our last one, and then I'll be giving you your assignment. So give this a try. I'm going to pause the video. We'll turn it back on after everyone's tried it. Okay, let's go over this. I'm going to take a volunteer to explain how to do this. Go ahead, Travis. Okay. Okay. Good. Now what? Okay. Good. Now what? Other side. Good. Wait, let's write it down first. 4y is less than or equal to. Okay. Now divide by 4. Y is less than or equal to -2. And don't forget to come down and write the word or in there. What's my graph going to look like?
-2 is going to be a closed circle, and there's going to be a line.
Okay.
And an open circle on 3.
Okay. Excellent job.
Don't forget your paddle boat.
Your assignment, yeah, I'm not going to draw the boat. You guys know I'm a terrible artist. Your assignment is going to be differentiated. You can decide which one you prefer. If you want to do an assignment out of the book, we're going to do page 204, 11 through 22. If you prefer to do Khan Academy, I've already recommended the assignment. It's called Compound Inequalities. You will need to get your 5 right in a row or show that you've worked on it for 45 minutes. And I should show you, I'll show you here in a second.
Yeah, come on.
What if we do both?